Welcome back. In this video, we are going to be talking about vertex word problems. When I use the word vertex word problems, what I'm talking about are real life situations where we're talking about the max or min. Whenever you hear something about maximum height, minimum revenue, anything like that, that is a vertex problem. That is going to be the point that is either the highest or lowest point for the parabola. Now, hopefully you remember. This is our little formula that we use to find the vertex, negative b over 2a. So in all these word problems, when they're asking for the maximum height, maximum revenue, any of that, we always need to start by using that formula to find the x value of the vertex. So let's dive right in to see what happens. So the first example we have is an economics example. A model for a company's revenue from selling a software package is R equals negative 2.5 p squared plus 500 p, where p is the price in dollars of the software. What is the maximum revenue? Or what price will maximize revenue? And then find the maximum revenue. All right, so in this case, our x is going to represent p and r is going to represent y. So don't let that confuse you if they're using different variables. All right, so here you can recognize instead of x we're using p, instead of y we're using r. Now I also want you to recognize, remember the basic structure of a quadratic. So you are going to have to remember that standard form quadratic so you can recognize that a is negative 2.5, b is going to be 500, and in this case there is no c shown. So that means our c is simply 0. Don't panic if there aren't three terms. It's okay. So just make sure you can still recognize that too, labeling out what your a is, what your b is, and if there is a c. So step 1. The first thing it says is what price will maximize revenue. So we have to find that x value, or in this case is going to be our p value. We're going to find that with negative b, so negative 500, divided by 2 times a. So divided by 2 times negative 2.5. Now, and this is very important for order of operations, okay? So very important that you do the denominator first, all right? Leave the numerator alone. Get that denominator, 2 times negative 2.5. That's just going to be negative 5. All right, so make sure you get a single number in the numerator and a single number in the denominator. Make sure you do that first. Now you can actually divide them. Negative 500 divided by negative 5 is going to be 100. And I want you to remember what that P represents. That P is the price that will maximize revenue. So since it's a price, we're talking about money. That is $100 that we just found. Now they say actually find the maximum revenue. Well, maximum revenue is R. So what that means is my second step, I'm going to have to plug that number back into the original equation to find the revenue. Because right now I have the price that will create a maximum revenue. Now I have to go back and plug it in. So I'm plugging that 100 back into my original equation. And remember, whenever you're plugging numbers into an equation, always put that number in parentheses everywhere that you're putting it. And again, just to review how to type this into the calculator. Negative 2.5. Then I need parentheses around that 100, which I want to square, then plus 500, and then again, when I'm plugging in the 100, I need parentheses around it. And that is going to give me 25,000. So for the software company, the maximum revenue is when they charge $100. And when they charge $100, they are going to end up making $25,000 total. All right, let's take a look at another example of this. So another example is a physics example. The equation for the motion of a projectile fired straight up at an initial velocity of 64 feet per second is h equals negative 16t squared plus 64t, where h is the height in feet, t is the time in seconds. Find the time that the projectile needs to reach its highest point. How high will it go? So again, we're talking about a maximum height, and this is going to come in two pieces. Now again, for this, don't panic. Your x is going to be represented by a t this time, and instead of y, we're going to be using h. So the first step is we need to find where the maximum occurs. So in this case, that's going to be what t value, what time is going to produce that maximum height. So again, I would label out my A is negative 16, my B is 64, and then there is no C shown. So that means C is going to be 0. So I'm going to plug in negative B, so negative 64, over 2 times A, which is negative 16. And again, to make sure that you're not making any simple calculator mistakes, you want a single number on top of your fraction, and then get a single number on the bottom of your fraction. So 2 times negative 16 is just going to be a negative 32. Divide those, and you get 2. Now, t is representing time. Okay, and it says that the time is in seconds. So the maximum height will occur at 2 seconds. Okay, 2 seconds after launch. Well, now I want to know what is the actual height. Well, now that I have the time that will give us that maximum height, all I have to do is plug that back into my original equation. And remember, whenever you plug something in, you want to put it in parentheses. So I'm plugging the 2 back into my original equation because I want to know what is that actual maximum height. So I'm going to go and I'm going to plug this in. So negative 16, and now I'm plugging in 2, so I need parentheses around it, squared plus 64 times 2, and again that 2 is in parentheses. Calculate that out, and I get that my maximum height that it will reach is going to be 64 feet. All right, so thank you for joining me for this. And again, make sure you have everything written down, and then please ask me any questions if you're confused on anything from this video.